That way it's quicker. We get done with it. And if you're in late, you just have that much time to answer the plicker. And remember, the plicker, I'm going to more often than not, you'll start seeing in your homework, you'll have -2 points because you didn't get the plicker correct. Because this one was almost out of your homework.
It was like 30.
It was, yeah. Okay, it says when he bought a new car totaling $18,996, including sales tax. If the sales tax rate is 9%, what is the cost of the car? So we have the total cost of the car is S, is going to equal the sticker price plus our price times the rate times time. However, in this problem, time is not a factor, so you don't need that. You just need the total price equals the price plus whatever tax you paid. Something to help you on these problems, if you'd factor out a P, you'd realize that it's just P times 1 plus your rate. And since our rate is 9%, you can rewrite 9, or you have to rewrite 9, as 0.09. 1 plus 0.09 is 1.09. So we could shortcut this by going just 18,996 equals P times 1.09. Then we would just divide both sides by 1.09 when we come up with $17,427.52. All right, so that is how you do those problems. Remember, even though this is an interest, it really is just interest, it works across the board when you're dealing with money and rates and taxes and so on and so forth. All right, questions on this? Questions from the homework?
I know you love it.
Yes?
27.
27. Ooh, this isn't your homework.
Yeah.
All right, 27 is the last one. Okay, 27 is investment income. It says Tara paid 1/2 of her game show winnings to the government for taxes. She invested 1/3 of her winnings in Jeff's coffee shop at 14% interest and 1/6 of her winning in Kaiser's German bakery at 12% interest. If she earned a total of $4,000 on the investments in 1 year, how much did she win on the game show? First of all, it's going to turn out that we don't care about the government at all. That has no bearing on the answer to this question. It says that she invested into 2 shops, and at the end of 1 year, she made $4,000 off of it. So let's look at the 2 shops and see how much she put in. Now remember, our interest, is that super tiny? It's kind of tiny. Our interest equals what we put in times the rate times the time, and the time is going to be in years. All right, so the first thing she invested in was a copy shop. So we'll just put copy. What she invested in the copy shop was 1/3 of her winnings. That is her P. That is how much she's investing in there. We don't know how much it is, but we know it's 1/3 her winnings. It says that it's a 14% interest rate. So we're going to multiply that by 0.14. And then that will be times 1 year. All right, then she invested in a bakery shop for 1 year. That was 1/6 of her winning. Times 0.12 times 1 year, because she got 12% interest back on that. Now she said after 1 year she added those 2 things up and she got $4,000 out of it. So that means copy plus bakery equals $4,000. In other words, just take those 2 equations and add them to each other. So we could just do 1/3 W without simplifying or anything. You should probably simplify it, make sure life a little easier. I'm not going to multiply by 1. We're going to add that to 1/6 W times 0.12, and that has to equal $4,000. You solve for W, and you come up with how much winning she had, which came out to 60 grand. Mary.
I got 59,701, but I confused because I used decimals and where I rounded. Is that just why?
Yep, that's why. Because I use fractions. I turn it into fractions, and I solved it back. One way you can refrain from using decimals and stuff is I would have maybe multiplied everything by 6. And would have got rid of these fractions. And then we could have moved decimal places if you wanted to, but you could have kept it all whole and you would come out exactly $60,000. Questions on this one? Yes?
Wait, so I got like 10 over 150 equals 4. Oh wait, that's actually...
It would have been 7 over 150 if you did it.
Okay.
And 1 over 50 for the other one.
So then,
Okay, Nicholas.
For number 24, can you like explain what's going on in the problem?
I don't know how to do that one. I just kind of made it up.
I didn't really understand like what it's asking.
Well, then we're on the same boat.
What? Okay.
Okay, let's go through it. So we have a real estate commission. Here's the end result of it. When you sell your house, you don't get all of that money, especially when you go through like a broker. So they're going through a person that's selling their house for them. So at the end of the day, they need to pocket $128,000. That means $128,000 goes in their bank account. That means they need to sell their house for more than $128,000 because they're going to keep losing some money. So it says specifically they're going to lose $780 on the top of their house right off the bat through closing costs. So right at the start, they need to sell their house for at least $128,780 to offset this. So that way when they sell their house minus that $780, they would have $128,000. That's if this was the only fee they had. But now they also have a 6% selling fee. So when they sell the house, they lose 6% of that money off the top too. So that's more money that's subtracted off the total cost of the house. So here's what's happening. Price of the house is P. So that's like what they have on the, that's how much the other people are paying. It's not how much I'm pocketing, it's how much I put on my sign for how much it costs. Now we have a commission that we have to pay, and we also have a closing cost that we need to pay. The commission is 6% of the total cost of the house. Not the stuff I want to pocket, but the total cost of the house. That means the amount of money that I'm going to receive for selling my house is how much I'm selling the house for, minus that selling price fee thing, minus $780 is how much actually is going in my pocket. Well, we said we want to pocket $128,000, so I want this to be $128,000. Then we just solve for P, and that's the sticker price of the house. Sticker price is $137,000 minus $780 minus closing costs will be $128,000 that you put in your pocket. Other questions? All right. Whoever likes word problems, here we go. We have an entire homework full of word problems. Now, I'm going to tell you right now, there are multiple ways to solve word problems. I find on these specific types of problems, we're going to have a distance, mixing, and we're going to have a work problem. Those are basically the three ones that you're going to kind of solve this way. I always make tables. It makes your life a little easier. I'm not going to take off points if you don't use tables. However, you don't use tables and you're way on this tangent, I can't figure out what you're thinking, you're going to lose a lot more points versus someone that's plugging in tables and just messes something up along the way. All right, so we have a group hiking down the Grand Canyon in 3 hours and 30 minutes. They return on a trail that was 4 miles shorter and hiked 2 miles per hour slower and took 1 hour longer. Yikes. What was their rate going down? This is a distance problem. They're talking about rates of speed, they're talking about distances, they're talking about time. This is a distance problem. As soon as you recognize something is a distance problem, think of the distance formula. The distance formula is rate times time equals distance, or distance equals rate times time. Then I'm going to put that on my table. I'm going to write it right in there. I'm going to say rate times time equals distance. Then we're going to look at what's happening. All right, in the very beginning, they're going down a path into the Grand Canyon. So I'm going to list one of my rows as down. Then they go back up. So we're going to list one as up. Mind-blowing stuff so far. There are times when you need to have a total column, and we'll talk about that down here. Don't force there to be a third row. Don't force there to be a third row. Just go with what they tell you. You'll see what I mean in just a second when you know you need to have a third row. All right, so let's go down. All right, a group hiked down the Grand Canyon in 3 hours and 30 minutes. So their time was, rather than doing 3 hours and 30 minutes, I'm going to put 3.5 hours. All right, that comes straight from that 3 hours and 30 minutes. They returned on a trail that was 4 miles shorter and hiked 2 miles per hour slower and took 1 hour longer. Let's look at the easy portion of that, the easier portion. This 1 hour longer. Why I'm going to focus on that is because that's the only thing I have on my chart right now is time. So if going down took 3.5 hours, 1 hour longer, I'm going to actually know that value. That's going to be 4.5 hours. All right, then let's look at the rate that they talk about. They're talking about 2 miles per hour slower. So if going up was 2 miles per hour slower, and I don't know how fast they walk down, let's pick a variable. Let's call going down x. The speed at which they went down was x. Now the rate of them going up would be x plus 2. I'm sorry, would it be plus or would it be minus? It's pretty silly. It should be minus because it's slower. If one was 30 miles an hour, the other one better be 28 miles per hour. All right, let's go across real quick. So this is all I know about the distance for the first one. Because the only thing else they talk about is there's a trail that was 4 miles shorter was on the up direction. So I know nothing about the distance on the first one, so we're just going to do the multiplication. So I'll do x times 3.5 equals 3.5x. Now the other bit of information that we know is that the trail going up was 4 miles shorter. So it's 4 miles shorter than this one. If this distance is 3.5x, then the distance going up needs to be 3.5x minus 4 because it's 4 miles shorter. That is the toughest part of this. I'm going to go over it and then see if we answer. This is the toughest part of it. Notice how I multiplied this straight across. And I didn't do the same thing here. The reason why I didn't do the same thing here is because I knew more information about this one than I did this one. It said specifically it's 4 miles an hour less. So I needed to find a way in the table to write that. They didn't talk anything about this distance, so you multiply straight across. So if they don't talk about it at all, you can just straight across and get that. If they talk about it, you should try to use it in terms of some other variable. Safa.
Could it work if you didn't use it?
Could it work if I didn't use it? You'd have to use it somewhere. So if you did x minus 2 times 4.5 hours, we'd have 4.5 minus 9. No. You'd have to come up with a different variable that specifically says that it's 4 miles less than the other one.
Okay.
So you need this little fact here that it was 4 miles less. Make sure it's included in your table. Whatever it says is somewhere in your table. What you could have done is you could have multiplied all this out and put it in this. And then in your equation, you could have said, like this minus 4 would have equaled that.
Okay.
Do you get what I'm saying? Somewhere in your equation, you'd have to have that. Yep, somewhere in the solving, you have to have that minus 4. All right, now we actually have 3 equations. We have 3 equations. We have x times 3.5 equals 3.5x. We also have x minus 2 times 4.5 equals 3.5x minus 4, and we also have 3.5x plus. But we'll talk about those other ones in just a second. The one I care about is this equation here. That x minus 2 times that 4.5 is going to equal 3.5x minus 4. Safa, if you would have just had that,
Yeah, that's what I was talking about.
if you would have kicked this out just like that, you just would have had to know to use the subtraction somewhere else.
Yeah, that's what I was talking about.
Yep. All right, that means we just need to solve for x. So we'll distribute this 4.5 to give me 4.5x minus 9 is going to equal 3.5x minus 4. Subtract 3.5 from both sides. We're going to have x equals negative 4. Add 9 from both sides. 9 plus a negative 4 is 5. We have x equals 5. That's the rate going down. We look at what we're looking for. We're looking for what is the rate going down. So x is our answer. So it's going to be 5 miles per hour. Yay. That one's probably the toughest one we're going to do today just because that minus 4. That minus 4 can go in a couple of different places like Safa noticed. The next one's a little easier. The next one is Shelley driving 40 miles from Peoria to Bloomington at 20 miles per hour. She drove back more quickly, so her average was 30 miles per hour. I want to highlight that average is 30 miles per hour. Since they're talking about an average, a total, or something like that, it means that we need to have 3 rows. We need to have a total row. So we are going to have a Peoria to Bloomington. We're going to have a Bloomington to Peoria. And then we're going to have a row going back. And that's dictated by this average tells me I need to have a total. The total trip. It's the only time you're going to have an average is if you have a total. And every time someone groans, I put 1 more on the test. Just saying. That's a true fact. All right. Now, since we're talking about miles per hour, we're talking about driving and such, we're talking about distance. We're talking about a rate times time equals distance. All right, now let's fill in information we know. Shelley drove 40 miles from Peoria to Bloomington, so her total distance was 40. And it also says she was going at 20 miles per hour. A rate is 20 miles per hour. Did they talk about the time?
No, sir.
Do we know the time, though?
Yes.
Yes, we do. I'm driving at 20 miles per hour, and I need to cover a distance of 40 miles. How long does it take me to do that? It takes 2 hours. So make sure if you ever know 2 numbers, you always know that middle one. And in other words, if we have our rate, which is 20, times our time equals 40, we divide 20 on both sides, and we have t equals 2. So our time just equals 2. Mary?
Would you technically know the distance, like the second line part of it is also 40 though? 'Cause it's
Sure. We also know that from Bloomington to Peoria is also 40 because it doesn't say anything about being longer or shorter, so we assume they take the same path, so it's also 40. We also know one more measurement. What's the total trip going to be?
80. Add it.
80. Add it, and we have 80. All right, cool. So we have a big chunk of this. We also have this little 30 miles per hour we haven't put in yet. So the rate is 30 miles per hour. Let me ruin everyone's day real quick.
No. I already ruined.
It is not this plus this divided by 2 equals 30. That implies that you're going that speed for the same amount of time. This one's going to be 2 hours. This one's going to be a different time. In fact, it says she drove back more quickly, so her average was 30 miles per hour. So we don't know her rate or how long she drove it. So we don't know the rate, so we'll just put an X down for that rate. Here's where people will make mistakes. Don't come up with a new variable and say it's X times Y equals 40. That is unsolvable. Instead, there you go. Instead, we're going to say, well, rate times time equals distance. So if I'm looking for time, time can equal distance divided by rate. In this case, our distance was 40. Our rate is going to be X, so it's 40 divided by X. Perfect. You can add every column of these except for one. You can add your distances, and it's going to equal. You can add your times, and they'll equal. You cannot add your rates. Because if I go 20 miles per hour over that way, 30 miles per hour back, I didn't average 50 miles per hour because I never even went 50 miles per hour. So this is the only column you cannot add. This is also, you'll see in just a second, mixing problems. You can't add this column as well. Every other column you can add. So we can do our times. We can do 2 hours plus however long it takes. The other one is how long the total trip takes. All right. Well, we have one equation that says 20 times 2 equals 40. That's true. X times 40 over X equals 40. That's true. 30 times 2 plus 40 over X equals 80. That looks like the one that we need to solve. So we're going to kick out that bottom one. So we're going to do 30 times 2 plus 40 over X equals 80. Let's distribute that 30. We have 30 times 2, which equals 60. We have 30 times 40. Well, 3 times 40 is 120, so that's going to be 1,200 over X equals 80. Just to shortcut stuff a little bit, I'm going to multiply everything by X. Actually, let's go ahead and let's subtract the 60 first. So we'll have 1,200 over X equals 20. Now I'm going to multiply both sides by X. We're going to have 120, or 1,200 equals 20X. So,
what?
well, how fast is she going?
60.
60. X equals 60.
Well, compared to, she was going 20 miles per hour.
Maybe she was.
Hey, real quick, let me finish this. So it says, what was her return speed? So we look at her return speed was, in fact, X, so it is going to be 60 miles per hour. Mary?
You also just found his time by being like you told us to figure out the later because you have the rate and you have the distance.
Say that again, I'm sorry.
Okay, sorry. So now how for the second row,
Mhm.
the RT equals D.
Yeah.
And then like in there.
So could we do the same thing to find this?
Yeah, for total.
Yeah. And then we do 2 plus 40 divided by X equals that new thing here.
Oh, so it's just like the last.
It's going to be the exact same thing. You're going to end up having the exact same numbers. It's just a different way. So what Mary's saying is, couldn't we just say, okay, 80 divided by 30 will give me a number here? And then we could do this plus this equals that number. Yes, you can. You'll get the exact same X value. Yeah.
How does 20 and 60 average to be 30?
Because look at how long she's doing it for. She is driving 20 miles per hour for 2 hours.
Mm-hmm.
And then she's going 60 miles an hour for 2/3 of an hour. So she's going for a much less amount of time. You don't just add and divide by 2 because that implies that she went 20 miles per hour for 2 hours. And if she'd go 60 miles an hour for 2 hours, then it would be rate plus rate divided by 2 if it was the exact same amount of time that she was doing it. Yeah. Okay. All right, the next one is a mixture problem. A mixture problem is kind of similar to a distance problem. We have a producer making orange drink that's 10% juice, and orange delight, which is 50% juice. how many gallons, of Orange Delight must be mixed with 300 gallons of orange drink to create 40% juice solution. This is going to be one where we need 3 rows because it says how much needs to be mixed with 300 gallons of orange juice to create a 40% juice solution. So that means we are adding everything together and we have to have a total at the end. So we're going to have 3 rows. We're going to have orange drink. We are going to have Orange Delight. And then we're going to have a mixture of the two. So we're going to have a mix of the two. Any mixture problem is going to have 3 rows. You pretty much can just assume. Your mixture problems will always have 3 rows. You'll have a row of something plus something equals that mixture. All right, now let's see what they talk about. They talk about a percent. They say it's got 10% juice in orange drink. So we need a percent column. Now you could do it with 10, but then you got to adjust for it. So it's just easier to put it as 0.10. So that comes from that 10% juice. Orange drink has 10% juice. Orange Delight has 50% juice, so that's going to be our 0.50. Then it says how many gallons of Orange Delight must be mixed with 300 gallons of orange drink to create 40% solution. So look at that gallons. That gallons means I need to have a gallons column. Juice solution. That's kind of what we have. That's kind of our last row.
No, I mean solution.
Yeah, solution. Or whatever you want. I just put total. It's just your total actual juice. Total juice is if I have 10% orange juice in there times 300 gallons, I want to know how many gallons of juice there are. So this is our total juice.
Why is there so much juice?
All right, so we have 0.1 times 300, which is going to give me 30 gallons of total juice.
You multiply the guys.
Yeah, I guess we could write that up there. Is percent times gallons equals total juice. All right, then it says orange drink to create a 40% juice solution. So our mixture needs to end up being 0.4. All right, do we know how many gallons of Orange Delight we need?
No.
No, we don't. So we're just going to put an X by it. But we can still do our multiplication because we don't know how much total juice is in that one either. So we'll just do the 0.5 times the X, which will give me 0.5 times X. All right, this is kind of like this problem here. This problem, you can't add your rates. This one, you also can't add your percents because that's going to be an average. But we can add these, and we can add those. So for our gallons, we'd have 300 plus X. And then for our total juice, we'll have 30 gallons plus whatever we're adding for the other kind. All right, now we're going to look at our different equations that we have. We have 0.1 of 300 equals 30. 0.5 of x equals 0.5x. And then we have this long one. This is the one we're going to solve. We can't work with this one because this one we just formed, and this one we also formed. So we're going to take that last one, and we're going to kick that one out. So we're going to have a 0.4 times 300 plus x is going to equal that 30 plus 0.5x. All right, so we just got to distribute that 0.4 to everything. So we're going to have 120 plus 0.4x equals 30 plus 0.5x. Subtract 30 from both sides. We're going to have 90 equals, subtract 0.4 from both sides. We're going to have 0.1x. And then we just divide both sides by 0.1, and you're going to end up with 900 equals x. So our question is, how many gallons of orange delight are there? We look for orange delight. How many gallons is x? So 900 is our answer in this case.
I feel like this room filled with juice.
Sure. All right. So that's 900 gallons. All right, so far we have done 2 distance problems. Distance problems, surprisingly, are generally the hardest because you can change them more when information is giving. Mixtures are almost always the same, where they give you like a master mix. Like they say, we have 400 gallons of it. It's just filling in blanks and going up and down. The last type of problem we're going to talk about are work problems. Work problems are like Steve can paint a house in 3 days, Fred can paint a house in 4 days. If they're working together, how many houses can they paint in 16 years? It's a lot of houses. It's, yes. Okay. Anywho, here's the thing about work problems. They're very, very similar to distance problems. You can think of them as being equivalent in what we're talking about. And let's talk about it. So we're on the ship with aliens, probably, with Brett can process the crew's medical history in 36 minutes. An android can complete the same task in 24 minutes. 1 minute after Brett began processing, the android began as well, and together they completed the task. Note that the task, if they just say the task, that means one task is complete. How long did the android work?
Does work also equal rate times time?
It does. How fast you work times how long you do that work equals how much work you can actually complete. So it works just like, so this is a work problem. Work problems are your rate times your time equals how much work is done, in other words, your distance in completion. So I'm going to write that right on the top of our chart. I'm going to go rate times time equals how much work you complete. Now we have 2 people. We have Brett and we have an android. Androids are people too. Now let's talk about Brett. It says Brett can process the crew's medical history in 36 minutes. That is giving you the rate at which Brett can complete something. So that is his speed. Brett can complete one task in 36 minutes. So he's going 1 task per 36. So his rate is 1/36. 1 task per 36, just like 1 mile per hour, or 16 feet per second. It's the same thing. It's his speed that he's working on. The android could do the same thing in 24 minutes. So the android's pace is 1/24. Now, we don't know much about how long they're going. It just says 1 minute after Brett began processing, the android began as well. Who has less time to work, Brett or the computer?
The android.
The android has less time to work. So if Brett is working for X minutes, how long does the android work for? Nora? X minus 1. So that's our time. Well, the amount of work that Brett will do is 1/36 times X, or you can put X over 36. And then, in fact, I'm going to put it as X over 36. It just is, it irks me when it's not that way. X over 36. Our other one will be X minus 1/24. All right, if you take all of Brett's work and you add it to what the android does, that's how much work they complete. So x over 36 plus x minus 1 over 24 equals all of their work. Equals the total work. Well, they want to know how long it takes them just to do one thing, one task. So the total work that they need to do is just one task. So we are going to have x over 36 plus x minus 1 over 24 equals 1 because they're looking for one task. We got that from here. Now we just need to solve this equation, and this goes back to clearing fractions. We need to clear that fraction, which means I need to have a common denominator between 36 and 24. Ross,
864.
can I have one smaller though?
Ross, delete 12 times 3.
Not 12.
72.
72. 72 is the one I'm looking for. You were going the opposite direction.
Wait, couldn't you?
If you multiply by 12, you still wouldn't clear it. They would go into it evenly. We wouldn't add to the fraction, but we wouldn't make it any easier. So if I multiply by 72, make sure you multiply it by everything. That means both sides. So 72x divided by 36 is going to equal 2x. Plus 72 divided by 24 is going to equal 3. And we'll have 3 times x minus 1 equals 72. Now it's just distributing that 3. We'll have 2x plus 3x minus 3 equals 72. 2x plus 3x equals 5x. Add 3 to both sides. We're going to have 75. Oh, man. It works out. X equals 15. And then I circle it, and I get one wrong from Mr. Pavian.
No. Oh, I know why.
What did I do wrong?
It should be 14.
It should be 14. Why?
Because Android.
Because it asks how long did the android work. The android worked x minus 1 minutes. So android, beep, boop, beep, boop, equals x minus 1, which will be 15 minus 1, which equals 14 minutes. Now I don't lose the point and get my test back. Oh, man, I should have read the directions. I didn't know I was supposed to draw an ostrich.
I thought it was a tree.
What?
I know.
Could have been a tree. Australia, mate. What?
Is that the one on the quiz?
Yes, draw